Hello everyone. Today we have to learn about method of variation of parameters to solve higher order linear differential equations with constant coefficients. In this type we have to learn two cases. Case number 1 for the linear differential equation of the second order with constant coefficients. Let f of dy is equal to x. This is general form of higher order linear differential equations with constant coefficients. Now in step number 1, we have to find out complementary function which is given by yc is equal to c1 into y1 plus c2 into y2, where y1 and y2 both are functions of x. Then particular integral yp is given by u into y1 plus v into y2. Here u is equal to minus of integral y2 into x divided by q integral with respect to x, and v is equal to y1 into x divided by q integral with respect to x, where q we can find solving this determinant. Now case number 2 for the linear differential equation of the third order with constant coefficients. Let us assume f of dy is equal to x. This is given linear differential equation, and then in step number 1 we have to find out complementary function. That complementary function is supposed like this: c1 y1 plus c2 y2 plus c3 y3. c1 c2 c3 are three constants because given linear differential equation is of order 3. Okay, then particular integral yp is given by u into y1 plus v into y2 plus w into y3. First of all we have to find out q. Q is value of this determinant. First row of this determinant is y1 y2 y3. Second row of this determinant is y1 dash y2 dash y3 dash, and third row is y1 double dash y2 double dash y3 double dash. Value of u we can find evaluating this integral. Integrand is in numerator. This is determinant. First row of this determinant is y2 y3. Second row is y2 dash y3 dash into capital X. Capital X is what? The right hand side of given linear differential equation divided by value of this determinant, that is q, integral with respect to x. Remember this formula: u is equal to integral of this determinant, its value, into capital X divided by q, integral with respect to x. Then v we can find evaluating this integral with minus sign. Minus sign is taken outside the integral sign. In integrand, in numerator, into capital X. Capital X is, right hand side of given linear differential equation divided by q, integral with respect to x. And then third, w we can find evaluating this integral of value of this determinant. First row is y1 y2, second row is y1 dash y2 dash into capital X, which is right hand side of given linear differential equation, divided by q, integral with respect to x. Means find the value of this determinant, that is nothing but q, and q you have to put here, here and here to find u, v and w. In this way we can apply variation parameter method to find particular integral. Let us solve example number 1. Solve by the method of variation of parameters. Linear differential equation is d square plus 1 y is equal to sec x into tan x. This is second order linear differential equation. So we have to solve this differential equation step by step. Step number 1, first of all write the given differential equation as it is: d square plus 1 y is equal to, right hand side is sec x into tan x. Now compare this differential equation with general form of linear differential equation, that is f of d y is equal to capital X, where f of d is d square plus 1 and capital X is right hand side of this differential equation, sec x into tan x. Now auxiliary equation is f of d is equal to 0. That is nothing but d square plus 1 is equal to 0. Solve this auxiliary equation to get auxiliary roots. D square is equal to minus 1, that is nothing but I square. Taking square roots on both sides, d is equal to plus or minus I. So these are auxiliary roots, plus I and minus I. This is one pair of complex roots. This is equal to, you can write real part is 0, so 0 plus or minus I. Compare this with alpha plus or minus I beta. Then alpha is 0 and beta is 1. Now complementary function according to these auxiliary roots, which is given by yc is equal to c1 cosine of cos beta x, beta is 1 times x, plus c2 sine beta x, beta is 1, bracket close, into e to the power alpha x, alpha is 0. Simplify this, since e to the power 0x, and which is equal to 1. Value of this exponential function is 1. Hence, value of this bracket complementary function yc is equal to c1 cos x plus c2 sin x. This is complementary function, and to find complementary function which gives 2 marks, compare this with c1 y1 plus c2 y2. Hence y1 is equal to cos x and y2 is equal to sin x. So let us find y1 dash. Y1 dash is equal to derivative of cos x with respect to x, that is minus sin x, and y2 dash is equal to derivative of sin x with respect to x, that is cos x. And using these values we can find q. Q is equal to value of the determinant y1, y2, y1 dash, y2 dash. Hence q is equal to, we can write y1 is cos x, y2 is sin x, and second row y1 dash is minus sin x and into cos x. So q is equal to, we can write value of this determinant cos x into cos x is cos square x, minus minus plus sin x into sin x is sin square x. This is trigonometrical identity, cos square x plus sin square x is 1. Value of q is 1. Let us find particular integral. Step number 2. Particular integral yp is given by u y1 plus v y2, where u is equal to minus integral of y2 into right hand side of given differential equation divided by q integral with respect to x. Now right hand side of given differential equation is sec x into tan x, means capital X is sec x into tan x. Hence u is equal to minus integral of y2 is what? Y2 is sin x into sec x into tan x divided by value of q is 1 integral with respect to x. Simplify and evaluate this integral. Hence u is equal to minus integral of sin x into sec x can be written as 1 upon cos x into tan x can be written as sin x upon cos x integral with respect to x. So u is equal to minus integral of sin x into sin x sin square x upon cos square x, that is nothing but tan square x integral with respect to x. Tan square x can be written as integral of sec square x minus 1 integral with respect to x, and then integral of sec square x is tan x, integral of 1 is x. Hence u is equal to, multiplying this bracket by minus sign, u can be written as x minus tan x. Let us find v. Consider this is equation number 1. Finding u and v, we have to put in equation 1 to get the particular integral. You know the formula for finding v. v is equal to integral of y1 into capital X divided by q integral with respect to x. And you know y1 is cos x into capital X is right hand side of given differential equation, which is sec x into tan x divided by value of q, which is equal to 1, and integral is with respect to x. Simplify this, integral of cos x into 1 upon cos x into sin x upon cos x integral with respect to x. This cos x gets cancelled with this, sin x upon cos x is tan x, integral of tan x integral with respect to x, and integral of tan x is logarithm of sec x. Okay, so particular integral yp is given by, put u and v in equation 1. Hence yp is equal to u y1 plus v y2. U is x minus tan x into y1 is cos x plus v is this value logarithm of sec x into y2 is sin x. So This is yp, which is particular integral. And then step number 3. General solution y is equal to complementary function plus particular integral yp. And general solution is given by y is equal to yc is given by c1 cos x plus c2 sin x plus particular integral is this one, x minus tan x into cos x plus sin x into log of sec x. And this is final answer, which is general solution of given linear differential equation. Let us solve sum number 2. Solve by the method of variation of parameters. Differential equation is d square plus 3d plus 2y is equal to e to the power x. In step number 1, always find complementary function. So step number 1, write given differential equation as it is, d square plus 3d plus 2y is equal to e to the power x. Compare given differential equation with general form, and you know general form is f of dy is equal to x. Hence f of d is equal to d square plus 3d plus 2, and capital X is equal to e to the power x. F of d is equal to 0. This gives auxiliary equation. Hence we can write d square plus 3d plus 2 is equal to 0. This is auxiliary equation. Solve this equation and get the auxiliary roots. This can be written as d plus 1 into d plus 2 is equal to 0. Then equating each factor with 0, d plus 1 is equal to 0 and d plus 2 is equal to 0. This gives d is equal to minus 1 and here d is equal to minus 2. Minus 1 and minus 2, these are auxiliary roots which are real and distinct. Okay, then complementary function yc is given by c1 e to the power minus 1 times x plus c2 e to the power minus 2 into x. Okay, compare this with c1 y1 plus c2 y2. Hence we can write y1 is equal to e to the power minus x and y2 is equal to e to the power minus 2x. y1 dash is equal to minus e to the power minus x and y2 dash is equal to minus 2 e to the power minus 2x. Okay, now we can easily find q. Q is equal to determinant value in which first row is y1 y2, second row is y1 dash y2 dash. Hence this is equal to y1 is e to the power minus x, y2 is e to the power minus 2x, y1 dash is minus e to the power minus x and y2 dash is minus 2 e to the power minus 2x. Okay, now taking multiplication of these two functions, e to the power minus x into minus 2 times e to the power minus 2x, this is minus 2 e to the power minus 3x, minus minus plus e to the power minus x into e to the power minus 2x, that is e to the power minus 3x. So value of q, this is equal to minus e to the power minus 3x. In step number 2, we have to find out particular integral which is given by yp is equal to u into y1 plus v into y2. Consider this is equation number 1, where u is equal to minus integral of y2 into capital X divided by q integral with respect to x. This is equal to minus integral of y2 is e to the power minus 2x into capital X is nothing but right hand side of given differential equation, which is e to the power x divided by q is minus e to the power minus 3x. Integral is with respect to x. Simplify this, minus minus that becomes plus. Hence u is equal to integral of e to the power x into e to the power x. Integral is with respect to x. Now this is equal to, we can write integral of e to the power x into e to the power x dx. Put power of this e to the power x is equal to t. Differentiating this with respect to x, e to the power x dx is equal to dt, and put here, so u is equal to e to the power t dt, which is equal to e to the power t. But t is nothing but e to the power x, so u is equal to e to the power x. This is value of u. Let us find value of v. V is equal to integral of y1 into capital X divided by Q, integral with respect to X. So y1 is e to the power minus X into e to the power X divided by minus e to the power minus 3X integral with respect to X. Simplify this. This is equal to minus integral of e to the power 2x into e to the power x dx. Again simplify, minus integral of e to the power 2x can be written as e to the power x its square. So e to the power x into e to the power x into e to the power x dx. Let us substitute power of e, that is e to the power x is equal to t. Hence differentiating this, e to the power x dx is equal to dt. Put here. So this is minus t into e to the power t dt. Evaluating this integral, applying by parts method, minus t into e to the power t minus 1 times e to the power t. Okay, now this is equal to 1 minus t into e to the power t. Now substitute value of t. So v is equal to 1 minus e to the power x into e to the power x. Now put u and v in equation 1. Hence yp is equal to, yp is u y1 plus v y2. But u is e to the power x. Y1 is e to the power minus x plus v is 1 minus e to the power x into e to the power x into y2. Y2 is e to the power minus 2x. So this is equal to e to the power minus 2x into e to the power x. This is particular integral after simplification. Okay. Now step number 3, that is general solution. General solution is given by y, and y is equal to yc plus yp. Now you can put yc means complementary function. Y is equal to, complementary function is c1 e to the power minus x plus c2 e to the power minus 2x plus yp, that is particular integral, is e to the power minus 2x into e to the power x. So this is general solution, which is final answer. Let us solve sum number 3. Solve by the method of variation of parameters. Differential equation is dq plus dy is equal to cosec x. This is third order linear differential equation with constant coefficients. So step number 1. In step number 1, write the given differential equation as it is. Dq plus dy is equal to cosec x. Compare this differential equation with general form. F of dy is equal to capital X. Hence, f of d is equal to dq plus d and capital X, which is right hand side of given differential equation, is equal to cosec x. F of d is equal to 0. This gives auxiliary equation, means dq plus d is equal to 0. This is auxiliary equation. We have to solve this auxiliary equation to find auxiliary roots. Hence, taking d common from here, into bracket d square plus 1 is equal to 0. Equating factors on left hand side with 0. D is equal to 0 and d square plus 1 is equal to 0. Hence, d square is equal to minus 1. D is equal to 0, comma d is equal to plus or minus I, which can be written as 0 plus or minus I, and comparing 0 plus or minus I with alpha plus or minus I beta, alpha is equal to 0 and beta is equal to plus or minus 1. Hence, complementary function is given by yc is equal to c1 into e to the power 0x plus into bracket c2 cos beta x. So c2 cos x plus c3 sin beta x. Beta is 1. Bracket close into e to the power alpha x. But alpha is 0. So e to the power 0x. We know e to the power 0 is 1. Hence complementary function becomes yc is equal to c1 plus c2 cos x plus c3 sin x. Hence yc is equal to, we can write in this form, c1y1 plus c2y2 plus c3y3, because we have to compare this complementary function with this, where y1, y2, y3 are functions of x. So comparing this with this, we will get y1 is equal to 1, y2 is equal to cos x, and y3 is equal to sin x. Differentiating this with respect to x, y1 dash is equal to 0 y2 dash is equal to minus sin x, y3 dash is equal to cos x. Once again differentiate this, hence second order derivative of y1 is y1 double dash which is equal to 0, y2 double dash is equal to minus cos x, and y3 double dash is equal to minus sin x. Using these values we have to find out q. Q is equal to determinant first row y1, y2, y3, second row y1 dash, y2 dash, y3 dash, and third row y1 double dash, y2 double dash, y3 double dash. Put the values in this determinant. This is equal to y1 is 1 cos x sin x, y1 dash is 0, y2 dash is minus sin x, y3 dash is cos x, y1 double dash is 0, y2 double dash minus cos x, then minus sin x. In this determinant, first column, first element is 1 and remaining two elements are 0. Then value of this determinant is nothing but cofactor of 1. So this is equal to value of this determinant 1 into bracket minus sin x cos x minus sin x. This is equal to taking multiplication sin square x plus cos square x. This is equal to 1. Hence q is equal to 1. Step number 1 is over. Now let us start step number 2, in which we have to find out particular integral. Yp is equal to uy1 plus vy2 plus wy3. Here u is given by integral of determinant y2, y3, y2 dash, y3 dash into capital X divided by q, integral with respect to x. So this is equal to integral of, now here y2 is cos x, y3 is sin x, y2 dash is minus sin x, and y3 dash is cos x into capital X is right hand side of given differential equation, which is cosec x divided by q. Value of q is 1, integral with respect to x. Let us simplify to get the value of given integral. Integral of cos square x plus sin square x into cosec x, integral with respect to x. But this is trigonometrical identity. Cos square x plus sin square x is 1. Hence u is equal to integral of cosec x, integral with respect to x, and which is equal to logarithm of cosec x minus cot x. So this is the value of u. Let us find v. V is equal to integral of determinant y1, y3, y1 dash, y3 dash into x divided by q, and integral with respect to x. So this is equal to integral of y1 is 1, y3 is sin x, y1 dash is 0, y3 dash is cos x into right hand side is cosec x divided by q. Q is 1, integral with respect to x. V is equal to integral of 1 into cos x into cosec x, integral with respect to x. So this is equal to integral of cos x into cosec x can be written as 1 upon sin x, integral with respect to x. Now cos x upon sin x is cot x, integral with respect to x. Integral of cot x is logarithm of sin x. This is v. Let us find w. Formula for w is integral of determinant v is with negative sign. This formula is with negative sign. So you can put here minus sign, minus sign, minus sign, and this minus sign. Now w is equal to determinant value of y1, y2, y1 dash, y2 dash into capital X divided by q, integral with respect to x. This is equal to y1 is 1, y2 is cos x, y1 dash is 0, y2 dash is minus sin x into capital X is cosec x divided by q. Q is 1, and then integral with respect to x. Okay. We have to evaluate this integral to get the value of w. W is equal to integral of minus sin x into cosec x, integral with respect to x. But cosec x is 1 upon sin x. So this becomes minus integral with respect to x, which is equal to minus x. Now put u, v and w in yp. You know yp is equal to uy1 plus vy2 plus wy3. So this is equal to u is logarithm of cosec x minus cot x, and y1 is 1 plus v is minus log sin x into y2. y2 is cos x plus w is minus x into substituting UVW in yp. U is logarithm of cosec x minus cot x into 1 plus v is minus log sin x into y2. But you know y2 is cos x plus w is minus x into y3. y3 is sin x. This is yp. Now step number 3, that is general solution, and general solution is given by y is equal to yc plus yp. Hence y is equal to yc is c1 plus c2 cos x plus c3 sin x plus this is complementary function. Now put particular integral logarithm of cosec x minus cot x minus logarithm of sin x into cos x minus x into sin x, and this is final answer of given linear differential equation. Let us solve one more sum. This is sum number 4. Apply the method of variation of parameters to solve this differential equation. D cube plus 6d square plus 12d minus 8y is equal to e to the power 2x upon x. So step number 1, write given differential equation as it is. D cube plus 6d square plus 12d minus 8y is equal to e to the power 2x divided by x. Compare this differential equation with general form of linear differential equation with constant coefficients. F of dy is equal to x. Hence f of d, function of differential operator, d cube plus 6d square plus 12d minus 8 and capital X is equal to e to the power 2x divided by x. This is minus sign, here also minus sign, minus sign. F of d is equal to 0 is auxiliary equation. Hence we can write d cube minus 6d square plus 12d minus 8 is equal to 0. We have to solve this equation to find its roots. So let us apply synthetic division method. Coefficients of d cube is 1, coefficient of d square is minus 6, coefficient of d is 12, constant term is minus 8. Synthetic division method is trial and error method. Let d is equal to 2. Now taking this first coefficient as it is, 1 into 2 is 2, minus 6 plus 2 is minus 4, minus 4 into 2 is minus 8, 12 minus 8 is 4, 4 into 2 is 8, now remainder is 0, means this is one of the root of this equation. Let us find another roots. This is cubic equation, so we want 3 roots. One root is 2, remaining 2 roots, 1 into d square minus 4 into d plus 4 into 1 is equal to 0. Now d square minus 4d plus 4, this can be written as d minus 2 square is equal to 0. Solving this gives 2 more roots, that are d is equal to 2 comma 2. Hence total roots are 3. d is equal to 2 comma 2 comma 2, means this is real root which is repeated for 3 times. Complementary function we can find yc is equal to c1 plus c2x plus c3x square into e to the power 2x. This is complementary function. Taking multiplication, we can write yc is equal to c1 into e to the power 2x plus c2 into x into e to the power 2x plus c3 into x square into e to the power 2x. Comparing this with c1 y1 plus c2 y2 plus c3 y3. Hence we can write y1 is equal to e to the power 2x, y2 is equal to x into e to the power 2x, and y3 is equal to x square into e to the power 2x. Let us find y1 dash, y1 double dash. y1 dash is equal to twice e to the power 2x, y2 dash is equal to 2 times x into e to the power 2x plus e to the power 2x, and y3 dash is equal to twice x square e to the power 2x plus 2x into e to the power 2x. Once again we have to differentiate this. y1 double dash is equal to 4 times e to the power 2x, y2 double dash is equal to 4 times x into e to the power 2x plus 2 into e to the power 2x plus 2 into e to the power 2x, that becomes 4 into e to the power 2x. y3 double dash is equal to 4 into x square e to the power 2x plus 4x e to the power 2x plus 4x e to the power 2x plus 2 e to the power 2x. This is y3 double dash. Hence q is equal to determinant e to the power 2x, x into e to the power 2x, x square into e to the power 2x. Now second row, that is twice e to the power 2x, 2x plus 1 e to the power 2x, and then 2x square plus 2x e to the power 2x. Third row, 4 times e to the power 2x, 4 times x plus 1 into e to the power 2x, 4x square plus 8x plus 2 e to the power 2x. Now find the value of this determinant. So this is equal to, we can write q is equal to twice e to the power 6x. Now step number 2, yp is equal to u y1 plus v y2 plus w y3, where u is equal to integral of determinant value of y2 y3 y2 dash y3 dash into capital X divided by q, integral with respect to x. This is equal to integral into determinant x e to the power 2x, x square e to the power 2x, 2x plus 1 e to the power 2x, and then 2x square plus 2x e to the power 2x into capital X is e to the power 2x divided by x whole divided by q. Q is equal to twice e to the power 6x integral with respect to x. And now we have to find out value of the determinant. After simplification, this integral becomes integral of x upon 2 integral with respect to x. So finally u is equal to x square upon 4. Let us find v. V is equal to integral of, with minus sign, determinant of y1 y3 y1 dash y3 dash into capital X divided by q into integral with respect to x. Hence this is equal to minus integral of determinant value y1 is e to the power 2x, y3 is x square e to the power 2x, y1 dash is twice e to the power 2x, and y3 dash is 2x square plus 2x e to the power 2x into right hand side is e to the power 2x divided by x whole divided by q. Q is twice e to the power 6x integral with respect to x. Simplify this. Hence v is equal to minus integral of dx, and this is equal to minus x only. Let us find w. W is equal to integral of, in numerator, determinant of y1 y2 y1 dash y2 dash into capital X divided by q integral with respect to x. Put the values. So this is equal to integral of y1 is e to the power 2x, y1 dash is twice e to the power 2x, y2 is x into e to the power 2x, y2 dash is 2x plus 1 into e to the power 2x into right hand side is e to the power 2x divided by x whole divided by q. Q is twice e to the power 6x and integral is with respect to x. Simplify this, finding value of this determinant. W is equal to, we can write integral of 1 upon 2x dx, and which is equal to half log x. Okay, this is w. Now put u, v and w in yp. Since you know yp is equal to uy1 plus vy2 plus wy3. Hence yp is equal to, that is particular integral, is equal to, what is u? U is, we have obtained this value, x square upon 4. U is x square upon 4, and y1 is e to the power 2x plus v we have obtained minus x, y2 is x into e to the power 2x plus w is this one, 1 upon 2 log x into y3, and you know y3 is x square into e to the power 2x. This is yp. Now step number 3, that is general solution. Y is equal to yc plus yp. Hence y is equal to, yc is c1 plus c2x plus c3x square e to the power 2x minus yp 3 times x square upon 4 e to the power 2x plus x square upon 2 e to the power 2x into log x, and this is final answer. Okay, in this way we can solve problems on method of variation of parameters, one of the most important method from this topic. So let us stop here. Thank you. Thank you all. Thank you for watching this video. Thanks a lot.